Okay, so this is lesson 2 on bonding units, and the focus of this lesson will be the Lewis dot diagram for molecular compound, and what we are taking a look on and what we are observing is when they are single bonded, double bonded, and triple bonds created between the outer atoms and the central atom. And when we have multiple of central atoms as well, we will take a look into the polyatomic ions. So let's start with a short review on terms of the molecular compounds. So molecular compounds, as we have been talking recently, even on the review of Science 10, are formed between two non-metals. So what is happening in a molecular compound? The electrons are shared, in a difference with the ionic compound where the electrons are exchanged. In this way, the two electrons are shared between two atoms, or one electron is shared between two atoms. And then what is happening here, then the electron is moving from one atom to the other. And so the electrons are shared. And in this way, they are forming molecular compound. So this is how molecular compounds are formed, or molecular bonds are formed. In order to draw the Lewis dot diagram for the molecular compound, we will follow this strategy, let's say. So we'll write the chemical formula of the molecular compound. We will identify the central atom. So what is central atom is the in the list of all the atoms that you see in the molecular compound is the atom with the highest bonding capacity, which means that it has the highest number of bonding electrons. Because as we said in the first lesson, the electrons that are single in an element, so let's say fluorine that has seven electrons in the outer shell, has a Lewis dot diagram like this. And what do you see here? Those electrons that are doubled, those are lone pairs, so they don't participate into creating bonds. However, this electron here that is single, it's known as the bonding electron, and is able to accept another electron to create the two electrons in the size around the element. So whomever has the highest bonding capacity will be able to take the lead or be called the central atom. Usually if carbon is there, carbon is the highest one, has 4 bonding electrons. So this is, if the carbon is there, then carbon is the central atom. And then what we will do is we will calculate the total number of electrons in a molecule or in the ion. And then we'll place the electrons around the central atom. So we'll start with the central atom, completing the octet rule. And then we'll move to the outer atoms. And we will complete the octet rule with exceptions. And then if there is any remaining, then we will place them as a multiple bonds in the central atom. Now remember what we have said about the octet rule. The octet rule means that we have to have 8 electrons around the atom. So when we have, let's say, neon has 8 electrons around the atom. When we have a fluorine ion or fluoride, then the Lewis dot diagram for fluoride is this one here. Okay, so octet rule means that the element has 8 electrons around the atom. Duet and the sectet is an exception to the rule. So we say it's the octet rule in general. However, we have the duet, which means that there are 2 electrons around the atom. And the example for it is hydrogen. Hydrogen is happy with 2 electrons, so is the helium. So helium is a noble gas, and it is happy with 2 electrons. Now this is related even to the energy level. So the first energy level is able to carry 2 electrons, and hydrogen and helium are the one that has only 1 energy level, and that means that they will be happy with 2 electrons in the outer shell. Sectet means that there are 6 electrons in the outer shell, and the exception for this is boron. Let's see and draw the Lewis dot diagram for methane. As you see, methane is combined with 2 nonmetals, carbon and hydrogen, and it has a chemical formula of CH4. So let's work through this problem and see which one is the the central atom, and which one are the outer or surrounding atoms. Okay, so when we take a look at carbon, carbon is on group 14, and it has 4 electrons in the outer shell. So that means that carbon will have 4 bonding electrons and 0 lone pairs. This is why I said that carbon, if carbon is there, carbon is always the central atom because it has the highest bonding capacity. And when we take a look at hydrogen, hydrogen has 1 electron in the outer shell, and since it is the exception of duet, has 1 bonding electron and 0 lone pairs. So therefore, naturally, we decide that the central atom is carbon. So now carbon is placed at the center, and then we said that we'll start counting the electrons for each of them. Okay, so 1 carbon, we'll start counting all the bonding electrons, has 4 bonding electrons, and 4 hydrogen that are in the formula will be 1 times 4, or 4 times 1 electron will be 4 electrons. And in total, what we will have is 8 electrons. 4 plus 4 is equal to 8 electrons. So let's start then placing those electrons, starting with the central atom and then with the outer atoms. So we'll have 1 hydrogen, 1 hydrogen, 1 hydrogen, and 1 hydrogen here. So when we start placing the electrons in around the central atom, then we'll go 1, 2, 3, 4, 5, 6, 7, 8. So all the electrons that are available are placed here. Let's see now if the octet rule for the central atom is satisfied, And in this case, the duet rule for the outer atom is satisfied. So on the central atom, what do we have is we have 8 electrons, so the octet rule is satisfied. However, when we take a look at the outer electrons, we have hydrogen, so the duet rule needs to be satisfied. This hydrogen has a satisfied rule. This hydrogen has a satisfied rule. This one here as well has a satisfied rule. And this one has a satisfied rule. So the Lewis dot diagram for methane, if we clean it up of everything, will be carbon at the center and then 8 electrons around the central atom. And we will have 4 hydrogen in 4 domains of the carbon. So let's take a look now. What is this level 1 single bonded of molecular compounds? So single bonded are created when 2 electrons are shared between 2 atoms. Like in the case of methane, what do we see here? Those 2 electrons are shared between the central atom carbon and the outer atom hydrogen. Each of them is sharing those 2 electrons. So this particular bond that is created between carbon being the central atom and each of the hydrogen as the outer atom is known as a single bonded. Let's see some examples on how to draw the Lewis dot diagram for nitrogen triiodide or the other ones that are here, in which we will see that the single bonds are created. So the chemical formula for nitrogen triiodide is Ni3. Let's take a look now and see which one is the central atom and which one are the outer atoms. So in this case, nitrogen is on the 15th group of the periodic table and has 5 electrons in the outer shell. So the Lewis dot diagram will be something like this. And for iodine, that is on the 17th group of the periodic table, it has 7 electrons in the outer shell. That means that the Lewis dot diagram will be something like this. So the bonding capacity for capacity for each of those atoms is 3 for nitrogen and 1 for iodine. So naturally, since the condition to have to be a central atom is to have the highest bonding capacity, nitrogen will be at the central atom. So let's draw the skeleton one. Nitrogen is at the center, and then we have an iodine in one side, another iodine on the other, and another iodine on the third side. So to complete the 3 iodines that we have in the formula. Now let's start counting the total number of electrons in the outer shell or in the valence shell for those for this compound. So we have 1 nitrogen and we have 3 iodine. Each of them has nitrogen has in the outer shell has 1, 2, 3, 4, 5 electrons, and 1 iodine has 7 electrons, which in total will give us 26 electrons. Those are the electrons that we have to place in this structure in order to see what is the Lewis dot diagram of this element. However, to do so, we always start with the central atom. So we complete the central atom with 8 electrons to satisfy the octet rule, but if it is boron, then 6 electrons. So 1, 2, 3, 4, 5, 6, 7, 8 electrons in the central atom, and then we start going on to the outer atoms. So 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So as you see now, the Lewis dot diagram for nitrogen triiodide is something like this. And each of the outer atoms are sharing the electrons with the central atom as a double two pairs of electrons. So this is forming that is known as a single bond. This one here. This electron here is the single bond. Let's take a look now to boron. BF3. Okay, let's see which one is the central atom and why, and how many electrons are in the outer. So for boron trifluoride, what we will see is boron is on the 13th place of the periodic table, and it has 3 electrons in the outer shell. So boron has 1, 2, 3 electrons. And iodine is on the 17th place. Oh, sorry, it's fluorine. Fluorine is on the 17th place of the periodic table, and it has 7 electrons in the outer shell. So it will be 7. Okay, so now the bonding electron for boron, bonding capacity for boron is 3, and bonding capacity for fluorine is 1. So therefore, boron is the central atom. However, keep in mind that boron is satisfied with 6 electrons in the outer shell. So we'll start drawing the Lewis dot diagram by placing the central atom at the center, and then the outer atoms in the outer sides. And we have 3 because the formula is dictating us that we have 3. Now we'll count first the electrons that each of them has. So we have 1 boron and we have 3 fluorine. Boron has 3 electrons, and 3 times fluorine has . So in total will be 21 plus 3, 24 electrons. So let's start placing those electrons in those central atoms initially, and then in the outer atoms. So we'll complete the central atom. And boron now is an exception. It needs only 6 electrons to be completed. So 1, 2, 3, 4, 5, 6. And then we'll start with fluorine, one of the fluorines. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And now in this case, boron, which is the exception, has 6 electrons. And all fluorines have 8 electrons to satisfy the octet rule. And we are good as the structure of boron trifluoride. Let's take a look now to silicon tetrahydride. And then what we will see here, the silicon is silicon has 4 electrons in the outer shell, and hydrogen has 1 electron in the outer shell. So the bonding electrons, bonding capacity for each of them is 4 electrons in for silicon and 1 electron for hydrogen, since hydrogen requires only 2 electrons in the outer shell. So then the central atom will be silicon. So now silicon is at the center, and then we have on each of the sides, we will place 4 hydrogen. So hydrogen, 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 hydrogen. And now let's count the electrons. We have 1 silicon and 4 hydrogen. That means that we will have the silicon will have 4 electrons, and 4 times 1 electron for each of the hydrogen. We will have in total 4 plus 4, 8 electrons. So let's place those 8 electrons, starting with the central atom, 1, 2, satisfying the octet rule. And then now hydrogen, each of the hydrogens is satisfied because a hydrogen needs only 2 to complete the outer shell, and as well the silicon that is at the center has 8 electrons, which satisfied the octet rule. Let's move now to the hydrogen gas. Hydrogen gas, the formula for the hydrogen gas is H2. On this case, we do not have a central atom because they have the same bonding capacity. However, the total number of electrons that we have, since we have 2 hydrogen, is 2 times 1 electron is equal to 2 electrons. So we'll have 1 hydrogen here and 1 hydrogen here, and we will place those 2 electrons in between. And what it is created now, each hydrogen is satisfied with the 2 electrons in the outer shell. So now let's see the next example is carbon, hydrogen, fluor, and fluorine. In carbon has 4 electrons as the bonding capacity. Hydrogen has 1 electron as the bonding capacity, and fluorine has 1 electron as the bonding capacity. So the carbon now becomes the central atom with the highest bonding capacity electrons. Let's count now the electrons that are in total on this. So we have 1 carbon, and we have 1 hydrogen, and we have 3 fluorine. So as we said, in the outer shell of the carbon atom, there are 4 electrons, and in the hydrogen there is 1 electron, and in the fluorine there are 7 electrons. So 4 plus 1, 5 plus 21 is 26 electrons. Let's start now starting with the central atom that is carbon, and then we'll place 3 fluorines and 1 hydrogen. So we will sort now those 26 electrons that are in the outer shell, starting with completing the octet rule for carbon. So 1, 2, 3, 4, 5, 6, 7, 8. And then completing the octet rule or duet rule on this case for the hydrogen for the outer electrons. So 8 electrons, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. And hydrogen is happy with 2 electrons that it's sharing with a central atom carbon. Fluorine is happy with 8 electrons. The other fluorine is happy with 8 electrons. The third fluorine is happy with 8 electrons, and carbon is happy with 8 electrons. And this will be the Lewis dot diagram for CHF3. Let's move now to the second level of molecular compound, where we are creating that is the double bonds. When double bonds are created, then 4 electrons are shared between two atoms. So we have an atom here and an atom here, and then we have 1, 2, 3, 4 electrons that are shared between each other. So let's take the gas, the example of the oxygen gas, following the structure that we have, the rules and what we said in terms of the single bonding. So oxygen gas has a formula of O2. Each of the oxygen has 6 electrons in the outer shell, so it will be 1, 2, 3, 4, 5, 6. The number of lone pairs for each of them, so 1, 2, 3, 4, 5, 6. The number of lone pairs on those atoms is 2, and the number of the bonding electrons is 4. So let's, in this case, they have the same bonding capacity, which means that we cannot decide which one is the central atom. However, so we will have those 2 atoms of oxygen, and then the total number of electrons of those 2 atoms of oxygen has is 6 and 6. 6 times 2, 6 electrons times 2 equals to 12 electrons. So let's complete the outer shell with of those electrons with the 8 electrons that we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So when we complete the outer shells of those 2 atoms with 8 electrons each, 2 that are shared between each other, then what will happen is that we will have way more. So we had 14 electrons in total, more than what actually are available to place. So then what do we do in this case? We erase one bond, and then we place them as, so we erase 2, we will erase 2 of those bonds and put them as the connecting bonds between the atoms. So we'll erase those lone pairs, we will erase those lone pairs and put 2 as the bonding electrons between atoms, creating on this case that is known as the double bonding. All right, so again, the oxygen gas has in total 12 electrons as the valence electrons in the outer shell. Without double bonding, the Lewis dot diagram will be like this. Which will result that we'll have 14 electrons in total, which is too many in comparison to what we have available to place. We cannot add electrons just because. So when we are taking those, erasing those 2 bonds here, any of the 2 bonds, and placing them as the double bond, so then we will have 1, 2, 3, 4, 1, 2, 3, 4, and then we will have the correct number of the electron that we have available. So let's take a look now to sulfur dioxide, and starting with the formula, defining which one is the central atom and how can we work with placing the electron. Okay, so sulfur has in the outer shell 6 electrons. 1, 2, 3, 4, 5, 6. Oxygen as well has 6 electrons. So bonding capacity for each of them is 2. We cannot define which one is the central atom. However, since we have 1 sulfur and 2 oxygen, because the formula is SO2, then at the center will be sulfur. So sulfur is here, and then we will have 1 oxygen on one side and 1 oxygen on the other side. Let's count now the total number of electrons that is available. We have 1 sulfur and 2 oxygen, which means that we will have 1 times 6 electrons plus 2 times 6 electrons, and this will be 18 electrons in total. Let's start placing those 18 electrons by starting with the central atom. So completing the outer shell of the central atom. So we'll have 8 electrons in the outer shell of the sulfur. Okay, and now we will complete the outer electrons with the electrons. So with 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, 8, 7, 8. So now the central atom and the outer atoms are satisfied with the octet rule, but let's count the number of electrons. So 1, 2, 3, 4, 5, 6, 7, 8 for the central one, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so that means that we have more electrons than what it is allowed to have. We have only 18 electrons to place. Okay, so then what do we do in this case? Since we have more electrons than what available electrons are, then what we will do is we will erase 2 of them and place them as the double bonds. So now let's count the electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So then the structure of the Lewis dot structure will be something like this. In one side, one of the oxygens will be double bonded, and on the other one of the oxygens will be single bonded. Okay, so now let's move to the next example, HCO. So hydrogen has 1 bonding electron, carbon has 4 bonding